The Second World War was more than just a conflict of nations. It became a proving ground for metallurgy, engineering, and the very concept of infantry firepower. This global war was fundamentally shaped by small arms. The effectiveness of the rifles, pistols, and machine guns carried by the common soldier dictated whether a trench was held or a city fell. The designs of the 1930s, often refined from the brutal lessons of the Great War, established the tactical landscape for the global catastrophe to come. In the United States, the foundational sidearm was the M1911 pistol. Designed by the incomparable John M. Browning, the M1911 was not conceived for elegance. It was built for pure, brutal stopping power, intended specifically to drop a charging man. Its improved variant, the M1911A1, was tweaked based on the hard-won battlefield assessments of World War I. This cemented its place as one of the most reliable and important military sidearms ever produced. For the standard infantryman, the Springfield M1903 rifle remained the primary weapon at the war's outset. This stalwart of World War I would continue service in variants like the M193A3, simplified for mass production. The sniper model, the M193A4, was often delivered to Allied forces struggling in Burma and the Philippines. Across the Atlantic, Germany was standardizing its infantry around efficiency and speed. The Karabiner 98K, adopted in 1935, was a masterful bolt-action rifle. Millions of these rifles would be delivered before 1945. This ensured consistency across the Wehrmacht's frontline forces. While the revered Pistol 08, the Luger, was celebrated for its accuracy and balance, it had a critical flaw. Its open toggle mechanism was notoriously susceptible to jamming when exposed to mud and dirt. Recognizing this, Germany replaced it with the mechanically reliable Walther P-37-8 in 1938. This semi-automatic pistol was designed to withstand the extremes of temperature and terrain, particularly the unforgiving conditions of the Eastern Front. But the true German innovation lay in the submachine gun. The MP-38 introduced advancements that defined the future of close-quarters combat. It featured an enclosed mainspring, a folding stock, and all-steel construction. Its rapid, devastating firepower in urban environments was crucial. The subsequent MP-40 variant prioritized mass production, utilizing welding and pressed components instead of extensive machining. This iconic weapon ushered in an era of swift, cheap, small arms manufacture. Elsewhere, the power of the submachine gun was already being realized by specialized forces. The Finnish Koen Pistuli M30s-1, the Suomi, was expensive and heavy but notably accurate. The Australian Owen, produced from November 1940, proved particularly advantageous in the Pacific theatre. Its bolt was protected against water and mud, providing crucial firepower to troops fighting in the jungle. The United States, however, was preparing for the greatest technological leap of the war. This was the widespread adoption of the semi-automatic rifle. The M1 Garand, which entered service in 1932, became known simply as the Garand. Gas-operated and feeding from an 8-round clip, it ejected with a distinctive metallic ping. This gave the average American soldier a tremendous advantage in sustained firepower over enemy bolt-action rifles. Over 5.5 million M1 Garands were delivered by 1945. Supplementing this power was the M1 carbine. This light, easy-to-handle semi-automatic was designed to equip non-infantry personnel. For squad support, the Browning automatic rifle, or BAR, served as a vital asset. For sustained defense, the M1917 and M1919 machine gun series provided reliable, belt-fed punch required on the front lines. The British, meanwhile, focused on rugged reliability. Their primary light machine gun, the Bren gun, was reliable and based on the excellently designed Czechoslovak ZBV Z26. In handguns, they favoured the robust revolver No. 2 Mark I. The British rifle saw modernization from the accurate rifle No. 3 Mark I to the rifle No. 4 Mark I. This final variant was optimized specifically for mass production and featured a 10-round magazine. In stark contrast, the Axis partners of Italy and Japan entered the war burdened by the legacy of obsolescence. While the Allies raced ahead, logistical inertia and cost forced them to rely heavily on designs that were decades old. Italian troops still carried the Modello 1880-9 revolver, introduced a year before the 1890s began. The Fusil M90-1 rifle, adopted in 1892, remained in extensive use. When Italy attempted modernization with the Fusil M38 rifle in 1938, they adopted a new 7.35mm caliber. This immediately created a logistic nightmare due to massive stockpiles of the older 6.5mm ammunition. Japan faced a similar dilemma. The standard rifle, the Type 38, adopted in 1905, was unwieldy and fired a low-powered cartridge. The standard officer's sidearm, the Type 14 pistol, introduced in 1925, was notoriously prone to reliability problems. Japan's machine guns, like the Type 11 light machine gun, suffered from complex feed mechanisms too intricate for field use. Their adoption of the new 7.7mm cartridge in 1932 led to the rifle Type 99. But this necessary upgrade was hampered by insufficient production and later severely compromised quality control. The foundations of the war revealed a critical truth. Technological parity was essential for survival. Nations relying on yesterday's weapons would quickly find themselves overwhelmed by the sheer volume and velocity of modern firepower. The sheer speed of the blitzkrieg exposed the limitations of traditional infantry tactics. When tank columns broke through the front lines, combat often devolved into brutal close-quarters fighting in towns and forests. In these moments, the standard bolt-action rifle, however accurate, was simply too slow. The early years of the war were a desperate global scramble for increased infantry firepower. Survival hinged on rate of fire. The immediate solution lay in the submachine gun. This was a compact weapon that could spray a volume of pistol ammunition in the confines of a building or jungle thicket. While the German MP-40 defined urban combat in Europe, the Australians faced the unique challenge of the Pacific theatre. In the steaming, corrosive humidity of New Guinea, weapons failed constantly. Mud, water, and grit clogged mechanisms, turning finely machined European designs into useless lumps of metal. The Australian response was the Owen submachine gun. Its designer, Evelyn Owen, engineered this weapon specifically to defeat the jungle. Its unique top-mounted magazine and sealed bolt mechanism protected it against water and dirt. This made it phenomenally reliable when other guns jammed solid. It provided Australian troops with the close-range superiority they desperately needed. But the real revolution lay in the standard rifle. Having witnessed the devastating sustained fire of the American M1 Garand, the Wehrmacht knew their ubiquitous Karabiner 98K was heading toward obsolescence. Germany desperately sought its own semi-automatic replacement, initiating a project that produced the Gewehr 41. The G41 was, however, a complex disaster. German engineers were initially reluctant to tap gas directly from the barrel, viewing it as a weakness. Instead, they opted for a complicated muzzle trap system to capture the gas and cycle the action. On the firing range, the system worked, but in the field, the G41 quickly became notorious. The muzzle trap required constant, fastidious cleaning. When dirt or grit clogged the mechanism, the rifle often became a single-shot weapon. German troops fighting on the muddy Eastern Front soon learned to distrust it. The turning point was not German ingenuity, but Soviet pragmatism. As the Wehrmacht swept into Russia in 1941, they captured thousands of Soviet Tokarev SVT-40 semi-automatic rifles. The Tokarev used a simple, robust gas-operated action, a design the Germans had initially rejected. Stunned by the effectiveness of the captured Soviet weapons, German designers immediately scrapped the flawed G41 system. They reverse-engineered the Tokarev's reliable gasport mechanism, leading directly to the significantly improved Gewehr 43. The G43 was a direct technological admission. To survive the Eastern Front, Germany had to learn from its enemy. Meanwhile, for Germany's allies, the quest for increased firepower was undermined by logistical inertia. Japan, attempting to enhance the battlefield performance of its infantry, introduced a new 7.7mm cartridge. This transition, intended to provide greater range and stopping power, created an immediate and crippling logistical nightmare. Supply lines struggled to cope with two entirely different calibers for standard rifles. Japanese forces in the field were often forced to use older, mismatched rifles with obsolete ammunition.
The desire for increased range had successfully strangled the supply chain.
The common Japanese soldier was armed with a weapon whose ammunition was rarely guaranteed to arrive. The immense, grinding war of attrition demanded not just better weapons, but weapons that could be produced faster. They had to be cheaper, and they had to be manufactured in overwhelming volume. The crisis of 1942 forced every major power to abandon meticulous crafting in favor of industrial pragmatism. Small arms became a direct measure of a nation's raw manufacturing capacity. Germany led this industrial leap with the creation of the MG-42 machine gun. The MG-34 was effective, but it was too expensive and required too much skilled labor. German engineers sought a revolutionary solution. The MG-42 was the result. A general-purpose machine gun built not from carefully machined components, but from extensive stampings and spot welding. It was exceptionally easy and cheap to produce. But it was the MG-42's blistering rate of fire that made it truly terrifying. It could fire up to 500 rounds per minute. Allied troops christened it Hitler's buzzsaw. The sound of the MG-42 defined the horror of German defensive positions. Facing the relentless German advance, the Soviet Union countered with sheer, devastating volume. Following the invasion in 1941, the USSR prioritized mass production of overwhelming infantry firepower. This led to the ubiquity of the PPCH-41 submachine gun. Designed by Georgy Shpagin, this weapon was the epitome of Soviet pragmatic engineering. It was simple, robust, and designed for rapid manufacture. Its crude finish was offset by a crucial detail, a chromed barrel interior. This significantly extended its life and reliability in the harsh Russian climate. Over 5 million PPH-41s were delivered, becoming the cornerstone of Soviet close-quarters fighting capability. Nowhere was this necessity more acute than in the besieged city of Leningrad. The city's defenders desperately needed close-range weapons. Out of this dire necessity, the PPS-42 submachine gun was born. Designed by A.I. Sudarev, the PPS-42 was a testament to survival engineering. It was designed specifically for manufacture within the city's defensive perimeter. This required minimal resources and time, utilizing simple stamping and riveting techniques. Refined into the PPS-43, over 1 million of these weapons were produced. It became known as a great weapon of the Eastern Front. Captured examples were so highly valued by the Wehrmacht that they were frequently pressed into German service. Across the globe, the drive for efficient mass production also characterized American small arms development. The M3 submachine gun, nicknamed the grease gun, was adopted specifically to replace the expensive and complex Thompson. Like the German MP40, the M3 utilized stamped and forged components for quick assembly. This ensured reliability and massive output, with over 600,000 delivered. Concurrently, the M1 carbine was produced in staggering numbers, over 6.3 million units. This ensured that even rear echelon soldiers had a reliable, effective semi-automatic weapon. On the Eastern Front, the Soviet Army relied on 2 machine gun workhorses built for endurance. The PM-1910, a variant of the venerable Maxim gun, was a heavy water-cooled machine gun. Its immense strength and reliability allowed it to withstand rough usage and adverse conditions. More versatile was the DP light machine gun, developed by Vasily Degtyarev. This gas-operated weapon, entering service in 1928, was the very definition of a workhorse of the Soviet Army. Its mechanism was brilliantly simple and strong, featuring only 6 moving parts. Its distinctive 47-round detachable drum magazine gave Soviet squads immediate, reliable firepower. This reliance on robust, simple, and overwhelmingly numerous small arms allowed the Soviet Union to absorb the shock of the German invasion. The final years of the war saw the technological fever pitch reach its apex. As the Axis war machine crumbled, German engineers had a final frantic burst of innovation. They introduced weapons that would define the next half-century of warfare. The most profound shift came not in the mechanism of the rifle but in the size of the cartridge it fired. The standard rifle round was overpowered for most infantry engagements, which typically occurred under 300 meters. Germany sought a compromise. The result was the Sturmgewehr 40A, the St. G44. It fired an intermediate power round from a high-capacity 30-round magazine. The St. G44 was the first truly successful assault rifle. It offered the infantryman a managed, controllable automatic fire capability. It was a revolutionary weapon, arriving too late and in insufficient numbers to change the course of the war. Its influence was immediate and enduring, setting the blueprint for every modern infantry weapon that followed. This focus on specialization also produced the FG-42. This technically advanced rifle was designed specifically for German paratroopers. Its limited production run symbolized the dilemma of the late-war German arsenal: brilliant but unsustainable engineering. Meanwhile, the Axis partners were facing a systemic collapse of quality control. The Japanese and Italian industrial base was strained past the breaking point. They were forced to compromise design for speed. The weapons handed to the final wave of Axis defenders were often a liability. Fighting on multiple fronts and suffering increasing shortages, the Wehrmacht integrated vast quantities of captured enemy weaponry. A German soldier in France might find himself armed with a captured French Fusil MAS-36. The German Ordnance Office meticulously designated this weapon as the Gewehr 242. On the Eastern Front, captured Pipichet 41s were highly prized and integrated into German ranks as the Maschinenpistol 709. This widespread adoption underscored the desperation of Axis logistics. Despite the chaos, certain designs proved their fundamental enduring quality. The Belgian-designed FN High Power, or GP-35, featured a groundbreaking 13-round magazine. It remained in service across the globe long after the war's end. The MG-42 set a new standard for manufacturing efficiency. It proved that devastating firepower could be achieved through stampings and welding rather than expensive machining. But perhaps the greatest testament to American industrial dominance was the M2 heavy machine gun series. Chambered in the powerful .50 caliber round, the M2 became the definitive heavy machine gun of the 20th century. It was manufactured in massive numbers for Allied nations. Its versatility, reliability, and immense destructive power ensured its relevance long after the final shots of World War II faded. The small arms of World War II did more than just kill. They dictated strategy, measured industrial capacity, and laid the technological foundation for the Cold War that immediately followed.